Hello and welcome to your next StableNet tutorial. Today we'll be providing you a walkthrough for basic features and functionalities in the recent release of StableNet 10.0 and for a look and feel of the system. Specifically, we'll be looking at the Rich Client user interface. Let's start with the system itself. StableNet consists of three elements. Here in the middle, you see the StableNet server. The server is connected to a database. In this case, we have a SQL database, MariaDB, which collects all the data that's measured by the system and the actual measurement device. That's a StableNet agent, abbreviated SN agent, which is the active part of the system that communicates with the network elements. So here we have built a dashboard that shows the overall health of the system as it monitors itself and gives you brief information and visualization regarding what the health status is. But let's look at the main components of the graphical user interface on the left side. And we'll be diving into these deeper later on. We have the themes. They're meant to provide you shortcuts to the most important parts of the system that you can navigate quickly through. So the most important theme is the measurement theme, which sits on top here. The next one is the agent theme, which is intended to manage the agent. This is a small lab system that we're looking at today, so we only have one agent, but in a large environment, you could have many more. Then we have the inventory theme. The inventory system gives you a device list and what devices are available in the system. You can navigate through an inventory tree, which shows you all the devices in a tree format, or you can go through individual devices separately. We'll look at this coming up. Then we have the reporting theme. This is the part where you run pre-configured reports, or you configure your reports yourself. We have the weather map theme. This is the theme where you have different visualizations that you can store and either use for repeated network visualizations, or you can use them as dashboards in the system. And last but not least, we have the network device automation part. This is where you have various options to configure jobs and automate the tasks in the network to a large degree, saving you a lot of time and effort, which is, of course, why we call ourselves the Automated Network and Service Management System. But let's start with the inventory. I go into the inventory device list, and for this short demo, I'm interested mainly in my Cisco devices. So I put a filter in there saying, hey, only show me Cisco devices that I have in the network. So I pick one. This one is in the virtual lab number 1, the core router number 1. It has the IP address 101314, and it's running iOS XR 702. So for the experts, this is a Cisco core router, which we have configured here. If you click on the Health tab, you can see on a quick overview what the average round trip time is to the device, minimum round trip time, availability, SNMP state, how long it's up. You see the type of information here, which you can sort by clicking onto the device. If you look at the Properties tab, there you can see what type of information the agent has gathered here. And it's quite a lot. So it's information about the device itself. It's information about tags. Tags are metadata in the system. And also information about the device itself, what types of neighbors it has, what types of routing protocols are on it, what types of modules are installed. So in this tab, you can see all the information that's in the device. If you're specifically interested in the interfaces, then you go to the Interface tab, which gives you the interface name, interface description, its IP address, and its MAC address, as well as the state when the interface was last discovered. The colors in green show the interface is up and running. If you want to see the connectivity, which interfaces are connected to which other interfaces, you click on the Connectivity tab. And this Connectivity tab gives you the interface description, device IP, physical address, and also what type of connectivity protocol this connectivity has been discovered. So here we have the Cisco Discovery Protocol. We have a routing protocol, and we have the link layer discovery protocol. Specifically in this scenario, we have always PF switched on the same. This is for the links, which show you what interface is connected to which interface and what information is applicable for this particular interface. You can also get a list of physical addresses associated to the IP addresses here, and you can get a list of the modules that are in the system, which are hierarchically organized. If you want to see what type of information has been gathered, you go into the discovery properties, and this shows you for this particular device what type of information, what type of SNMP information is queried here. In this case, everything which has been set to true is collected through the SNMP data. And last but not least, if you click on the neighborhood, You see the device centered here in the middle and all the neighborships it has, all the neighbors it has. And if you hover over the device, you can see a ping chart that shows you immediately what the round trip times are, what operating system it's running, device model, what IP it has, and so forth. And this is, of course, also configurable. So next we go into the measurement theme. We can talk quickly about some of the capabilities here of StableNet. One of the most important parts is the measurement theme. So we'll switch to the default view that you'll encounter when you open StableNet. You have an alarm count, you have the monitoring status, and you have the device status here. Most important for getting around in StableNet is using the navigation tree. In the navigation tree, it's where we're using the tagging system. Again, what we call this meta information that's attached to an object. This meta information allows you to organize and navigate or filter your navigation tree in accordance to what you want to see. It's really a great way to customize your network. Typically, you do this in a topological or organizational structure. So just to give you an example, that would be a country, region, city, point of presence, maybe department on duty or whatever organizational aspects you have. In this case, we have a lab network. We've organized ourselves, and it's set up somewhat differently. We've organized our tree in terms of use cases, and here you can see the use cases that we've implemented. So if we want to show something about cloud monitoring, we would just use the cloud monitoring filtering, which has been implemented here. And then it shows you all the parts in our lab network that are associated to cloud monitoring. Same goes for the data center. So in this case, you'll only see devices with measurements that are associated with the use case data center. So let's go back to the default measurement tree because measurements and monitors are the key parts in the system after the devices have been discovered. So again, here we can go ahead and look at our company InfoSim. In this case, we have the InfoSim headquarters. And under the headquarters, we have the backbone, we have the infrastructure, we have the StableNet devices, and we have our virtual lab, which we discussed earlier. This time I'll take a Juniper router, which is in virtual lab number 2, in its core router number 1. Underneath this device, the router, you see the sections, interfaces, processes, specific measurements, and a round trip measurement. So the round trip measurement comes in default. Within that round trip measurement, there's the round trip monitor. And as you can see, in case everything's green, as here is the case, that means everything is okay. It's a data collection, so we collect data via SNMP, and then we monitor that data by putting a KPI, which is in the monitor sitting underneath the measurement. In this case, I show you the measurement quickly. So this is the name of the measurement. This is the configuration of the ping. You can tweak this ping configuration by expert level. You can assign meta information to this. This is about the navigation you just seen in the tree. You assign it to a group or customer selection. So you have the ability that only certain people in your organization can see this, or you have a multi-tenant system with which you can structure different things for different customers. Underneath this measurement, there's the monitor, so we can look at the monitor. The monitor has some general parameters, which you can see here. It has alarm notification groups, so you can put an alarm notification here and then send it to an email address, put an OK event in there, send it via SMS, or send it to a syslog server, or send it to a trap receiver. But let's go back and modify such a measurement for the sake of demonstration. So in this case, it's quite simple. The measurement is meant to be between 0 milliseconds and 2000 milliseconds to be okay. If I change this, I can add another threshold. So for the lab, I add a net threshold between 0 and 0.1 milliseconds, and saying only in this range, which is very small. This is okay, and anything between 0.1 and 2000 should throw me a major alarm. Obviously, this is not a realistic setting. It's just for the purpose of demonstration. So now I can change also the expert settings to something which is much smaller than what we have here in the default. To show you a result in a very short time frame, I'm going to go ahead and do that. So what I change here is the state machine. The state machine allows you to give an alarm a grace time. It gives you an okay probation period time and looks at the number of state changes before an alarm is thrown out, because the basic idea behind StableNet is to monitor the system, but not to send out too many flags or warnings for short-term events in your network. So if I change this here and I change that setting, then we'll see in a short time that this monitor will change its color. So I connect now to this device, ping the device to give you an idea of what the actual round trip time is. And you see the ping response is coming in about 0.4 milliseconds. Okay, this is very, very short because the device is actually installed on the same server as the agent. But in the usual network, this would probably be a higher number, of course. So if we now wait for a little, then you can see that the monitor is going to change its color because now it figures out that the ping response time is actually higher than the measuring time that I've put into the system. Yeah, so ideally we can fast forward this and then you'll see that the state change on this measurement will have changed. So if this changes to yellow, it's a warning. Then you also see the warning for this device. The warning will go up the tree to the warning of the entire lab and up to the highest severity state in the entire network. So if you have a severity state in your monitor, then you see this always on the highest level. Now it's appeared, so we have a warning on the round trip time, we have a warning on that particular router, and we have a warning coming up into the VLab. This is actually impacted by the measurements that we defined, and in a little while, since things aren't going to change, the monitor is still in the same range, it will turn to red. What we can now do is we can analyze the problem that we just encountered. So I click on this round trip time. I go to the analyzer and it shows me I have an issue. It shows me what the actual round trip time is. So obviously you can change a lot of parameters here, like the time intervals or the time interval of 1440, which corresponds to an entire day. And as you can see here now, the measurement is turned red. And we do indeed now have a major severity after the grace period that we configured. What you can also do if you want to compare different measurements in the analyzer, you can take this round trip time and you can click on this, put it into an analyzer, and then you have the comparison with the thresholds in there. So there's plenty of possibilities how you can tweak your analyzer by selecting different charts and diagrams here, change any time period, or drill into a particular measurement. So yeah, I'm not going to go into more details here because the usage and I think the use cases are quite plentiful. After looking at the analyzer, now let's have a look at different options for analysis. One powerful option is the group analyzer. It gives you statistical information about the given device. So in this case, you have the monitor availability DNA. And as we've created the error about the average round trip time, we just did that. You can see here when the device was actually down in comparison to all the other instruments which are in the system. Obviously, you can change again the time interval, the date ranges, the statistic type, and other parameters to determine what type of report you actually want to see. Another powerful analyzer is the category analyzer. It shows you the categories that we're measuring this particular device. And again, as we have we've created the problem of availability, you can see the availability here is turned red, while all the other measurements we have in the system like CPU load, failure, memory, and so forth are completely okay. So these are the measurements that you can see here underneath the respective categories. With regard to measurements, this is just a ping measurement and availability measurement, which is a very simple example. StableNet has a very powerful measurement option, or many options, I should say, which you can see if you create a new measurement. So from the measurement types StableNet offers, you can add runtime measurements like the ping that we just used, but can also add Cisco-specific measurements like IPSLA for the protocols or application-based measurements in terms of window management interface, TCP connecting measurements, and other measurements that are depicted here. One of the powerful measurements is the so-called business process script. The business process group measurements are application-based measurements that we deliver with the system that give you measurements on, for instance, database capabilities, database availabilities, disk space, and other things that are not necessarily related to network devices. Those measurements are typically used for host systems and other systems. External measurements tend to be the most powerful of the measurements we have here. They use external scripts providing data, which can then be read into StableNet and used for very advanced forms of data collection. Another group of measurements are SNMP templates and SNMP interface measurements. We have the flow rules and flow statistic measurements in there for the fault. We have long SNMP trap and drive tools, which are logic rules that you can put between different measurements with Boolean operators to create dependency. simply saying if a measurement is down at this measurement, it will give you a warning. And finally, we have status measurements for syslog traps and other statuses in the system. We're now looking at the biggest part of the screen in the graphical user interface, which is the dashboard area. The default dashboard area that comes with StableNet shows the open alarms in accordance with severity. So we have major severity, minor severity, and marginal severity defined in this network. Then we have the monitor status and the pie chart with major, minor, marginal, worn, and other status colors for which there is no data in this network. We also have device status where we have 9 devices. We have 1 marginal and 8 minor alarms currently showing. The dashboard area is the widget-based system that we have that can be highly customized. We already have some highly customized use cases here in the lab environment. First of all, that's the StableNet overall health monitoring that we've created that shows you the server with key KPIs, that shows you the database with the KPIs that we are measuring here, and there is the StableNet agent. So these are the use cases we've also defined here in the tagging system. The self-monitoring use cases are visualized by this weather map. For other use cases, we have also created some weather maps. This is an example for the Cisco SDN infrastructure, which is called ACI. And we're monitoring the ACI-based network with StableNet as an umbrella system here. Another use case here is the IoT or Internet of Things bike rental station in Würzburg. In the city where we're located here in Germany. You can see parking lots with available bikes, which the operator can monitor in order to see how the bikes are distributed in the city and where they actually are in the parking system. Another use case is the Wi-Fi overview that we've created. This is our own network here in the 3rd and 4th floor of our headquarters, where the corresponding access points of our Wi-Fi are monitored. Typically, you'd create something like an overview with multiple dashboards, and this is then an example where you can freely choose which type of weather maps you want to visualize and have displayed, for instance, in your network operating center on a larger screen. This brings us to the event area. Fault monitoring and alarm handling is one of the key functionalities in StableNet, and here at the lower part of the screen you can see the open alarms area. You see the action events that are logged, you see trap entries. We don't have any here. You can see the syslog entries and the StableNet log entries. So the alarm area can easily be filtered, for instance, for major alarms, minor alarms. You also see you can have comments and descriptions if they're applicable or desired. Inbuilt root cause analysis allows to suppress alarms that are dependent on other alarms. This is with the root cause dependency in StableNet. Unfortunately, again, we don't have any here. And again, if the ticket daemon is installed, then StableNet can be integrated into systems like ServiceNow and forward the alarm information into those systems to be worked on, gets the ticket status back, and alarms can be acknowledged. Once you click on a specific alarm, like the office monitoring, then you see instantly the tag tree would open, the corresponding monitor that's thrown the alarm, and the window comes up that gives you background information on alarm data, alarm impact, and alarm symptoms. As we continue our tour, we can have a look at the agent theme. The agent is the key component in the StableNet architecture because it communicates with the network, collects all the data, stores it, and sends it up to the server. In this system here, we have one local agent on board. It's on a local host address and it's connected to the StableNet server. And once you select it, you see the key parameters about the system here with the top right window. Once we can select a new agent for onboarding provided with an IP address, then we put in a port number, 5100 is default, login name, password, then we can test the connection and set up the individual properties. Add tag category and tag values as desired, and we can assign the users as well. Once we click Finish, the agent is onboarded. This button updates all the agents of the server and synchronizes them with the data, and the agent expert provides you with detailed information about the agent itself. It contains license information, what type of licenses are required and installed on the agent. It gives you an overview on the alarm scripts that are installed on the agent, the business process scripts that are installed on the agent, the data store, how it's used, and how much space you have left. And here also you can configure the flow, syslog, SNMP trap receiver, IP imports. In addition, in this section, there are the flow queries, where you can define net flow queries and select the data and protocols for flow monitoring, and the same dialog for the syslog queries. Next, I switch back to the inventory theme. In the inventory system, I filter for the Cisco router. We looked at this router before. We can jump to the neighborhood graph where it's centered, and it shows all the routers which are directly connected to it with the neighborhood level of 1, and additional connections by increasing the neighborhood level to 2. As a network engineer, you're also interested not only in these neighborhoods, but you'd want to know about other layer 2 and layer 3 logical connections within the network. For this, we offer the Network Service Analyzer, which shows you either point-to-point connection based on MPLS, layer 2 VPNs based, LDP or BGP, layer 3 VPNs also based on BGP, or the routing neighborhood based on ISIS and the OSPF areas. Yeah, so as an example, we can look at OSPF area 0, which is our Cisco core in this case. And you see the devices, the interfaces, and the peered devices immediately in the table. That can also be depicted as a weather map and stored as a weather map. Again, the tooltips would show you the ping chart in this configuration and the triangle of our 3 Cisco core routers, core router 1, 2, and 3, here are visualized. So if I click on this, it creates the weather map, and I can enrich that information if I'm now interested in, hey, what are my layer 3 VPN connections for this particular VPN? Then I can click on these and see immediately what's connected, the connectivity on the loopback addresses and the import and exported route targets. Same for the ISIS areas and the BGP sessions for the different autonomous system numbers that we've installed here in the system. Yeah, which gives you a view of the entire Cisco network that we have in the lab and the transit routers which connect the 2 virtual labs together. We believe this is really helpful for looking into logical connectivity sessions, logical architectures that overlay the physical connections in your network, etc. Next, we'll have a look at the reporting theme. I select here reporting. It offers me reporting jobs, which are already in the system, and I can create HTML-based reports, PDF-based reports, and Excel reports. So let's start with a new reporting job. First, I give it a name, so I'll create a small report about the SN agent. Then the schedule. For scheduling, I only require a report to run once in this case, so I'll set as active. And now I can configure through the report's definition. I use the standard template and the mail format HTML. I add my reporting component, so I want to have 2 reporting components in there. And now I redefine templates to fill for the reporting control components that should be contained. So I want to have a chart statistic in there on this one. I select a measurement for the system load and finish that component. And then I want to have the weather map with the KPIs for our self-monitoring of the whole platform. I select StableNet Health Weather Map, and then I'm done with the report. I can again assign tags and tag values to it, and assign an administrator who has access to this component. And that's basically it. I'm done. My new report has now been created. I select it, generate the report immediately. On the HTML reports, I see now that the report has been created. I select it. We see the StableNet system load diagram with CPU load of 1 minute, 5 minutes, 10 minutes, as we selected before in our measurements, and the previously introduced overall system health map with the KPIs we defined on there. Now finally, we have a look at device automation. Device automation is one of the most powerful functionalities in StableNet, and we will certainly have a number of additional tutorials in this domain. But for now, let's look at the jobs that we have available for automation here. There's an automated backup job, and then we have a backup job defined which runs on a daily basis for our virtualized lab. This job creates device backups, and I again take the virtual core router, number 1, in my Cisco environment. Open that up, and down here you can see the backups that have been taken recently. So if I'm now interested whether something's been changed between February and March, I can select those 2 times, click on Configuration Comparison, and there I can see the differences, what's been changed and what's been added during those 2 configurations. Here we have configuration jobs. The configuration jobs are jobs that are based on what we call snippets. Snippets are elements of configurations. These are command line syntax which can be extracted with variables if desired and can be used universally across different network element vendors for harmonizing or setting up configuration. For instance, here we have one that's set up to configure NTP server or to configure specific syslog hosts. All these snippets can be freely defined, changed, modified, and added to your liking. A very important part is the discovery jobs. These are responsible for discovering the network infrastructure, network elements, rediscovering on a regular basis, automating the measurements and the monitors that are taken in the system. So everything that was shown here before has been discovered at one point through a discovery job that we have in the system that's automated and is updated regularly. Then we have the policy checking jobs. These are jobs for checking whether or not the right system configurations are in given devices. And here we have a job created for vulnerability checking, which checks whether deployed devices are subject to any vulnerabilities and exposed to them. We have another tutorial on that specifically. And finally, we have the workflow and process management jobs. Those are jobs that are combine workflow jobs that can be combined together to run in a certain sequence, depending on the outcome of the previous job. And these are a little bit more advanced configurations to help automate more complex network tasks. So that was a lot in a short amount of time. I understand. I hope it was helpful. And again, we have a whole portfolio of tutorials, snapshots, videos, short webinars that dive deeper in any one of these specific topics as well, which we're expanding upon constantly. I appreciate your time for coming in and checking out some of the core functionalities of StableNet 10.0, and have fun with StableNet. Thank you.